In permutations and combinations, we're going to talk about the fundamental counting principle, the permutations, and combination. Now, permutations will be without any circular permutations, which is kind of part of the old curriculum. But if you've taken work or pre-calc 30, some of these will be very familiar. It's pretty much identical. Basically, you should be able to understand counting problems, simplify factorial expressions, solve factorial equations, explain how factorials relate to permutation combinations, solve situational questions, and compare and contrast permutations versus combinations. So the first thing that we're going to talk about is fundamental counting principle in permutations. Now, the fundamental counting principle is basically just a way of dealing with permutations. It's just a special kind of a permutation. So the counting principle goes that if you have, in a series of n decisions have to be made. The first decision could be made x1 amount of ways, second could be x2, third x3, all the way to the nth decision. Basically, what it comes down to is however many decisions or how many options you have for something, all you're going to do is you're going to multiply them. So in our first example, if you have Michael wearing shirts, hair clips, pants, and shoes, if he has 6 shirts, 4 hair clips, 3 pairs of pants, and 5 shoes, all you're going to do is multiply those numbers together. And if you multiply them correctly, well, definitely not subtraction, it should be multiplication. Michael would have 360 different outfits to choose from. So how that looks as a tree diagram is if he has 6 shirts, you have shirt 1, shirt 2, shirt 3, shirt 4, shirt 5, and shirt 6. But no matter which shirt he chooses, he's going to have 4 different hair clips to choose from. So you could go with shirt 1 and then hair clip 1, or hair clip 2, or hair clip 3, or hair clip 4, which is going to still fit the exact same thing, if he chose shirt 2. So on and so forth. And then if we're talking about pants, well, you could have pants 1, pants 2, pants 3. So he could choose shirt 1, hair clip 1, and pant number 1, or shirt 1, hair clip 1, and pants 2, or pants 3. Of course, this gets very convoluted and very, it's very complex when we have so many different options. And just let it get out of the way. We still have shoes. So we have shoes 1, shoes 2, shoes 3, shoes 4, and shoes number 5 to choose from, no matter which path you go. So this is how a tree diagram would look. Very convoluted, very complex. That's why you won't have very many tree diagram questions. They'll be very basic, but this is the way. By the end of this, there'll be 360 different paths that Michael could choose. How about a 4-digit number that has to be formed using the numbers 1, 3, 4, 5, 6, 7, 8, if the digits can't be repeated? So again, when we're talking about this fundamental counting principle, we're talking about the number of decisions or the number of options. If we have to have a 4-digit number, 1, 2, 3, 4, how many options, how many options or decisions does he have for the first digit? Well, you can count 1, 2, 3, 4, 5, 6, 7. We need to make that. We have 7 options to choose from for our first digit. If it can't be repeated, though, as soon as we choose the number 4, we no longer have 7 options. So your number could be 4, 1, 3, 6, because none of those digits repeated. It would take a very long time to list all of them. That's why we use this fundamental counting principle. So for the first digit, we'd have 7 options. As soon as we use one of them, so that one's used, we have 1, 2, 3, 4, 5, 6 digits left, 6 options, 6 decisions left. Let's say we use the number 1. Well, now we have 1, 2, 3, 4, 5. And continue on, then we'd have 4. So that's just one of the options that we have is the 4,136. But that's not all of the total. Because 7 times 6 times 5 times 4 is 840. So there would be 840 numbers that would only use the digits 1, 3, 4, 5, 6, 7, 8, and the digits aren't repeated. Now we're going to go into something more even complex, is how many positive 4 digits can be used using the numbers 0 to 9. So again, we're talking about a 4-digit number. Once again, these are options, or how many decisions we have to choose from. If we're looking at this first digit, from the numbers 0 through 9, there are a total of 10 options. But if we have the definition of a 4-digit number, is that we actually have to have a number in each of these places. The number 0, 2, 4, 6 is a 3-digit number. The number 0987 is once again a 3-digit number. So that first, that thousandth or thousands decimal or place can't be the number 0, which means it can be any of the numbers from 1 to 9. So we have 9 options to choose from. After that, it doesn't matter. It doesn't say anything about repeating. So obviously, we can repeat. We can have the number 8,888 because it's a 4-digit number and it's positive. It doesn't say anything that we can't repeat our digits. So as soon as we get over that hurdle of that thousands place, we would have 10 options left for the hundreds place. Because if we chose the number 7 as our thousands, we could use the number 0 for our hundreds. We could use the number 0 for our tens. We could use the number 1 for our ones. All that this fundamental counting principle is saying is those are the options that we have. In reality, we have 9,000 4-digit numbers, which is actually true. Because you'd have to start at 1,000, go all the way up to 9,999, which is 9,000 digits. Then we can get into more complex equations, like how many different license plates can be made if you have to have 3 consonants followed by 3 digits. Again, we're only really concerned ourselves about options. So those will be our consonants. These are going to be our digits. So once again, we're talking about options or decisions. I like tossing this one in just to kind of tie back into our English. Well, a consonant is anything that's not a vowel. We have 5 vowels, which means that we have 21 consonants. The question doesn't say anything about repeating or anything. So we could repeat the letters B, B, B. We just have 21 options to go with anything. And then digits, well, digits are the numbers 0 to 9. So 10, 10, and 10. And if you multiply that out, 9,261,000. Okay, even more complex one. It says 3 different letters followed by 3 digits if the first digit cannot be 0. Now, it doesn't say anything about the digits can't be repeated, just the first digit can't be 0. 3 different letters. Well, how many letters do we have in the English alphabet? We have 26. So if we have 26 options for that first one, it has to be different. We can only have 25 options left. Oh, erase that, make that actually look like a 5. And then 24. That's 26. Okay, now if this first digit can't be 0, it means that we'd have 9 options. Well, it doesn't say anything about any other digits, so we'd have 10 options. We'd have all digits from 0 to 9 for those last 2 spots, which comes out as 14,040,000. So just by looking at either of these, we have lots of different license plate options. Last question, try and make it quick, make it easy. Choosing from the digits 1, 2, 4, 5, 7, 8, and not allowing repetition of digits, answer the following. How many positive 2-digit integers can be formed? So 2-digit option, we can't have any repetition. How many options do we have? 6 for the first one. And if we can't repeat, we'd have 5 options left. Nice, quick, and easy. Now the question is, how many odd 2-digit integers can be formed? The definition of odd means that the last digit has to be odd. How many of these digits are odd? 1, 5, and 7. So this is going to go backwards of what we usually do, is we instead of starting with our first digit, we're going to have to start at our second digit. We have 3 options for that first digit. Now, if it can't be repeated, if we chose the number 7, we would have 5 options left for the first. 5 times 3, 15. Last but not least, talk about 3-digit integers. Oh, it's even talking about even. Well, which digits are even? The 2, the 4, and the 8. To define even, we only care about that last digit. So we'd have 3 options for that first spot. And as soon as we get rid of one of our options, say we get rid of the 2, we have 5 options left for here, and we have 4 options left there. The reason, again, is that repetition of digits. We can't, not allowing repetition of digits. So let's see, 20 by 3 is 60. And there you go with fundamental counting principle. Oh, never mind, you have some more. Hannah plays on a school soccer team. School uniform has 3 different sweaters, 3 different shorts. How many different variations can the coach choose from? Well, there's 3 different kinds of shirts or sweaters, and there's 3 different types of shorts. So 9. In the next season, you're adding a red 4th type of shorts, red, black stripes. 3 times 4. So we're just going back to that basic. You're looking at the options. How many options do you have for top? How many options do you have for shorts? Now, I do love lock questions. They are actually quite fun. First, we'll also talk about lottery, but we'll talk about lottery stuff later. 2 high school locks open with correct 3-digit codes. Now, of course, I know that you guys have a little bit of leeway. Like if your number is 37, many times you can get it to work out of 36 or 38. But we're not going to talk about it. We'll talk about if it has to be exact. How many different codes are possible if lock A rotates from the number 0 to 39, and the second rotates from 0 to 59. If lock A allows repetition of digits, a 3-digit code, how many options do you have for the first number? Well, from 0 to 39, there'll be 40. And if you can, by chance, have the number 555 as your locker com, there'll be 40, 40, 40, which works out as 64,000 different combinations. Now, lock B does not allow repeated digits. So lock B has to go from 0 to 59. There will be 60 options for the first number, 59 options for the second, and 58 for the third. So there will be 205,320 different combinations. So which lock is more secure? Obviously B, because it has more combinations. And if it takes 10 seconds to go through a locker com, it's going to take a very long time to get this one. Unless your com is very simple, or if you're one of those people that leaves their locker com written on the tape that's on the back of your locker, might not be the most secure. But anyways, there's our lesson. You can go have some fun.